Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome everybody again to another episode of our show, bringing you another really fascinating guest today, involved in some really unique areas of science, technology, and innovation. Today we have the honor of being joined by Dr. Victoria Coleman, who is the Chief Scientist at the United States Air Force, where she currently serves as the Chief Scientific Advisor to the Secretary of the Air Force Chief of Staff, and the Chief of Space Operations, providing assessments on a wide range of scientific and technical issues affecting the department's mission. And in this role, she's involved in identifying and analyzing technical issues, bringing to attention of department leaders, interacting with various principals, operational commanders, combatant and command, acquisition, science and technology communities, ultimately to address cross-organizational issues and provide various solutions. She also interacts with other services and the Office of the Secretary of Defense on issues affecting the Department of the Air Force technical expertise, as well as serving on the Executive Committee of the Air Force Scientific Advisory Board, and is the principal science and technology representative of the Air Force to the civilian scientific and engineering community and to the public at large. Dr. Coleman previously served at University of California, Berkeley, where since 2016, she held an academic research appointment at the Berkeley Center for Information Technology in the interest of society, leading the science and technology policy on microelectronics, as well as interesting efforts to develop tools for countering digital authoritarianism. And then prior to accepting the role as Chief Scientist of the Air Force, Dr. Coleman served as the 22nd Director of DARPA, overseeing a large suite of disruptive and innovative programs, as well as leadership of their Microsystems Exploratory Council. She began her academic career as a lecturer in computer science, but in between that and government, she was involved in many private sector initiatives, SRI International, Intel, Hewlett-Packard, Yahoo, just to name a few, as well as serving as the Chief Technology Officer of Wikimedia Foundation, the nonprofit that supports Wikipedia. A lot of very interesting topics to get into with her today. We're honored to have her. Dr. Victoria Coleman, thank you so much for taking the time to come on the show.
Thank you for having me. It's good to be here.
Yeah, it's such an exciting and interesting journey that you've been on to date in these different domains in academia, industry, government now, of course. Take us back a little bit, if you would, and sort of introduce us to the early days, because, I took a look at some of your early publication history, which revolve around sort of these themes of security, reliability, safety, sort of computer architectures. What started this all off? Tell us the beginning, if you would.
Well, I think, as they say, all is well when it ends well. So I think hopefully we're ending well. But going back to those early days, and this may sound a little cheesy, but it's true. 1969, my dad went out and bought a TV, so we watched the landing of the moon. And it changed my life. I decided there and then I was going to be, a scientist. I knew I was going to be a computer scientist because that was, it was the new unexplored thing that looked to be like the most challenging thing around. So I figured that's for me. So here we are, decades later, and 3 degrees in computer science. So, I think I got that part right. So I was like pretty focused. I think in many ways, it defined, my career, but, of course I wasn't alone. I think it inspired, an entire generation of people that became scientists and engineers. In some ways, when I look back at that, I think, wouldn't it be nice if we had such a project again to inspire the next generation of scientists and engineers. So, as you can tell by the accent, I wasn't born here. So I was born in Greece. I got it into my head that I was going to study computer science. So I left Greece when I was age 18. I went to the university in England and started my career there. One of the things that fascinated me, and it was aligned very much with the topic, my academic topic, my scholarly topic, was, how do we put trust in systems, either because they're secure or because they're safe or because, they have integrity. And I kind of, naturally fell into working in defense-related systems. The first real airplane I worked on, and this shows you how old I am, was the F-14.
Okay.
So, those of us that had the opportunity to watch the various Top Gun movies will have seen how glorious an airplane that was. I was fortunate enough to work on the air data computer, which is the thing that controls the sweeping of the wings in that airplane. Because, when it lands, right, it's like it slows down, but then it really needs to be delta in order to be able to, to store it on the aircraft carrier. So, that really kind of started a lifelong, love and fascination that I've had with, all things avionics. And it's interesting, toward the end of my career now, I end up in the Air Force, where, I really can help perhaps influence, some of the decisions, some of the technology decisions that we're making that affect, airplanes that are much more advanced than the F-14 was. And also what is interesting is, once in a while I get to ride in one. So next week we'll be out at Nellis. We have our annual command and control conference. I'm going to ride again in an F-16.
Nice.
There is nothing in this world that I was drawn to avionics, to these very complicated machines that could do amazing things. I spent most of my career in the commercial sector, building out technologies that, when I look at them now, are pieces that we're going to desperately need to bring into our mission, including airframes. Fairly simple things these days, like doing over-the-air updates, which are, happens to your phone without even knowing it.
Right.
For us, it's a massive exercise, which is, it's aspirational at this point. You may wonder, how do you go from building mobile phones to, being the chief scientist of the Air Force? In truth, I never kind of departed from, this love that I had, of all things defense and avionics in particular. While I was serving in these various positions, executive positions and others in the commercial world, I always maintained an advisory role. So I was a member of ISAT, which is one of DARPA's advisory groups. Then I was a member of the Defense Science Research Council. Then I stood up the Microelectronics Exploratory Council, and then I joined the Defense Science Board. So I always managed, like, in my view, to balance the two things. In the view of my managers in those positions, I always did way too much for the government. I always, I typically got into trouble with my managers. Like, what are you doing in DC again? So, at the end, even I got wise and figured, well, if that's what I like doing, why don't I do it for a living? It took me a long time to get to that epiphany, but I got there. So here we are.
Excellent. As you walk through so your time in the private sector and looking at organizations, like Intel, Yahoo, Samsung, and I had a chance to you're on many interesting patents at that time related to personal clouds and digital assets, as you were saying, stored across different devices, and sort of you were there at the beginning of the development of this weird thing that we call the cloud now. And then you transition into DARPA, and the DARPA theme is quite interesting because we've had the honor of profiling several DARPA thought leaders, as well as some of the other ARPAs that are out there, and it's quite interesting how when we talk to the folks from the DARPA of the world, they love that model, right? It's very different than what you run into in industry, and we see a lot nowadays. Like I know you're the 22nd head of DARPA, but Dr. Dugan, I think a couple of leaders at DARPA before you, is one of the ones out there sort of now trying to take that DARPA model and make it happen in different areas in the private sector. Talk a little bit about your DARPA experience, if you would, and a little bit of, how the contrast and what you ran into with sort of traditional private sector with that really unique model of high risk work and high reward.
It's so interesting, right? So there's only one DARPA, but there are many DARPA wannabes, right?
Right.
Both government as well as the private sector.
Right.
And I will tell you the one thing that all these wannabes have in common is that none of them have quite gotten it right. So there is a special recipe at DARPA that I think that makes it very unique. And it's not that, it's rocket science, it's not. But it's hard to get all those factors together and do so on a consistent, long-term basis so that, the institution gets enough time to develop, if you like, both, its ways of working, but also the brand, right, that you need in order to continue succeeding. So, you need to have some early wins. And DARPA, happened to have the right recipe at the right time. And I think that made all the difference, right? So, I mean, for me, what can I say? I still remember I was down here, I was sitting in this desk when I got the call that I was selected to be the director. And I ran away screaming. I ran upstairs screaming. It was one of those moments that you never forget. It was an incredible honor. And many people are going to be the DARPA director. It's one of these positions that I think many people kind of covet. I mean, even though it's in terms of seniority, it's not a particularly senior position, but there is so much legacy and so much respect and love for the institution that many of us would love, and I was fortunate enough to have an opportunity to be part of that and contribute to its well-being. Mm-hmm. So my time there, and this may sound bizarre, DARPA is full of incredible people that are thinking out of the box every day about ways to upend the world. That's not the job of a director. The job of the director is very different. First of all, it's like, don't break anything, right? And you can break stuff really easily. But the other one is and my focus was, how do I make this institution even more capable of delivering on this mission of using this recipe to do amazing things? And that honestly starts with empowering the program managers. It starts with removing obstacles. Because even our wonderful DARPA over 60 or so years of existence, organizational debris accumulates, and it makes it difficult for people to get things done. I mean, what we see from the outside tend to be the wonderful success stories, but for every one of the stories, there's a program manager that went there, with their hair on fire, as Tony Taylor used to say, and sometimes it would take 18 months for them to be able to pitch an idea. It's like, no, that's not okay. We need to fix that. So my focus, honestly, was twofold. One was, how do we make the life of a program manager in DARPA, which is short, typically about 4 years, as productive as we can for the individuals and the institution, but also, how do we strategically position ourselves so that we don't have blind spots? when you look at the DARPA, the 6 or 7 offices, it's a broad kind of portfolio of things that the agency is working on. Doesn't mean to say that they're working in all the areas where we need to have the DARPA model apply and do its best. There are many areas like that I knew, back then we had gaps. We still do have gaps. So my focus was identifying those areas and then putting resources onto them. You mentioned earlier digital authoritarianism. This was one of the areas where I felt we had a gap, and we still have a gap. So I think, again, the job of the director is don't break anything, empower your program managers, get stuff out of the way so they can move fast. And also, strategically think about the portfolio to see where is it you could go higher to begin to build, enough, enough critical mass in the agency so that they can go and do the incredible work that they can do. Only they can do, but, focused in these emerging domains.
And just while we're on the topic, because you led DARPA, but you also led this Microsystems Exploratory Council, and I noticed that speaking of sort of blind spots or sort of gaps, recently there was this Hudson Institute seminar sustaining U.S. microelectronics leadership, and I guess in an interview you were quoted talking about we are as the United States we're so poised to leap ahead in fabrics, materials, devices, but we need and obviously this has been in the news last few months. We need a goal for this leadership in chip design and manufacture and not have a lot of our eggs in certain baskets. Can you just say a few words about sort of where we are, where you believe we should be in terms of that particular gap?
So the Microelectronics Exploratory Council, like the other advisory groups at DARPA, had precisely this goal in mind, namely blind spots, right? So, right. DARPA is a small organization. There are 250 people. It doesn't mean that you can cover the entire kind of spectrum of things that you should and could be working on. So this other groups have this job of looking over the horizon and say, gap here.
Yeah.
Now, when I was there and before I went there and after I left the agency, I felt that microelectronics was an area where, as a nation, we were falling behind, and it's an area that I worked in for many years. I worked at Intel. My academic career had a significant component of microelectronics, and what I could see was that we don't lack for investment on the innovation side. Like we DARPA, the NSF, other agencies, NIST. There's a lot of money that's going into a variety of fabrics. Not as much as I would like. I think we need to do more in that regard. But then, the challenge becomes, how do you take that and have it, cross the proverbial valley of death? Which, by the way, in microelectronics is more like a canyon. It's not a valley, right? Because the amount of money that is needed in order to scale a microelectronics innovation is humongous compared with a software solution. So, I run an AI startup. I paid, I think, like $5,000 a month to Google to get access to their data center. That was all the investment I needed to make. If you're going to go make microelectronics, you're talking billions of dollars, right? So in order to be able to go from, a promising, innovation to the promised land, if you like, you need significant investment, which we did not have. I am, really excited now with the CHIPS Act that finally is coming to being, that we will get some of that gap kind of, filled, if you like. But my epiphany, if you like, on that was that it doesn't matter how much money you put in discovering fabrics, if you're not able to prove them out at scale, nobody will ever give you the money that you need, these billions of dollars to invest to scale it. And therefore, as a nation, we are not able to leverage our investments in innovation, and we will continue falling behind. So this was the kind of the rationale behind the microelectronics commons, which is, let me see now, I think it's 9903 in the CHIPS Act. That's the segment of the law that defines that.
Mm-hmm.
Commons is all about building a national infrastructure that will allow us to prove out these innovations at scale here at home. Because today what happens is, we may, the NSF, for example, may invest in neuromorphic computing here at Stanford next door. And they did, hundreds of millions of dollars. When time came for the professors to take the 2 or 3 devices that they were able to build in the fab at Stanford to make, 1 million of them, so that they could show that actual computational loads do perform a lot better in these architectures, where do you think they went to? They went to Tsinghua, because that is the only place that has the facilities, either that or MyMake in Belgium, which is super expensive and they can't afford it. So if you think about that, and again, that was my epiphany, we believe, and it's true, that, we have ceded, manufacturing to the Far East, Taiwan, China, and so on. And, we kind of worry about that, but, it's much more worrying to know that you've actually ceded your ability to innovate to them.
Right.
Because it's not just about discovering the lab, it's about being able to make that connection that actually, yes, this discovery will lead to better outcomes, and therefore, you, Mr. VC, or you, Mr. Government, should go invest. We ceded that to them, and that's not okay. Right. So the Commons, which was funded, I was so excited, the $2 billion, it's now been executed out of the Undersecretary for Research and Engineering, will create this critical infrastructure here at home that will allow us to prove out our innovations without being held hostage, really, to others.
Yep.
So it's kind of really satisfying to see. You go from identifying such a scary gap,
right,
actually being able to work, across the aisle and work with all these many different stakeholders to create an outcome like that, eventually will begin to create a solution. And this is not the beauty of working in government. People complain all the time, with good reason, that working in government is infuriating. And trust me, it is infuriating. But, if we have patience, and if we are singularly focused on a specific problem to solve, not the universe, but a specific problem to solve, you can move mountains if you get the government aligned. So once in a while, we get on these home runs, and life is good. So right now, life feels good.
Excellent. So, moving now into the current role, chief scientist, United States Air Force, and again, this is an area that we have been honored to profile some of these different innovators, and it's been a bit of an epiphany, looking at things, like we had the folks on from the Air Force Research Labs talking about this iNeurals program, which is just such advanced neurotechnology. Colonel Diller from AFWorks, talking about how he's in the Pentagon, but it's basically a venture capital firm looking at next stage innovation. Joel Moser from Space Force joined us. You're at the epicenter of all this now, and sort of, I guess, everything comes to you in terms of where these scientific directives begin. Talk a little bit about the role, a little bit about technologies, initiatives within this portfolio that you're most excited about, and a little bit, what happens when that colonel or whoever it may be knocks on your door, say, what, I want an invisible airplane that shoots laser beams and whatever. What do you do with these projects?
So I gotta tell you, it's hilarious, actually. First time I took an F-16 flight was about a year ago, and I got off the plane and I thought, oh my God, first of all, I wanted to die. But, once I got my bearings, I thought, the limiting factor in these airplanes is the human being. It's quite clear. So I turned around and I said that to my pilot. He said, ma'am, never say that again. Okay, I got it. I'll never say that again. However, I do get the opportunity, and it's such an honor, right, to work with people like him, including folks that this is the beauty of the Air Force, right? So
Right.
because we have our civilians, and then we have our officers in in uniform. They're such amazing leaders, right? So a lot of the change that you will see, in technology, in ways of working and so on, comes from them. So again, the trick, as I was telling you earlier, with the program managers at DARPA, is how do we empower them? I think a big part of my job, and I think when I do it well, is to empower those O4s, the O5s, the O6s. So give you a great example. It was about a year and 3 months ago, roughly. I had a briefing from three junior officers. They were working on something. I forget even what the name was back then, but they wanted to take autonomy and begin to deploy it in the mission. Autonomy, because there's a bunch of autonomy results at DARPA and other places, but how much do we actually have in practice in the jet when they're flying a mission? Very little. So they put this this plan together as volunteers. They have their day jobs, and then in the evenings they would work on this. It was all about taking the leaf out of the Tesla model, and instead of believing that you can go from a fully kind of human-driven car to a fully autonomous car, that you needed this many millions of miles between the two, so that you could learn and the system could learn with human supervision before you actually give full autonomy. In the Air Force, this is where we are stuck today. We're like we have planes that we fly, and then we're going to be at a place with, for example, with collaborative combat aircraft. One of the key aspects of the strategy that Secretary Kendall has, that's supposed to be fully autonomous. Well, how are you going to get there?
Yeah.
You need this interim step. Well, these group of colonels or lieutenant colonels came up with a solution. Turns out a solution that involved my old agency at DARPA. The thinking was, we should go get a bunch of F-16s and kit them out with a safety box, if you like, on which you drop autonomy code, so that you could have actually a human pilot in the loop as you were experimenting with the autonomy code. That's an incredible kind of insight. Without that, every time you deploy autonomy code, you have to go do certification. It'll take you 9 months between drop codes. You know how often Facebook does drop codes? Thousands of times during the day. So you need to get to that point. How do you get to that? Well, you get to that with this interim step. Internally, we'll call it Venom. And after a year of advocacy and helping this team and representing them and talking the ears of my colleagues, we actually got it funded. So we will go get the 6 jets, and we will kick them out, and they will become part of our core competency in translating autonomy from the lab to missionized autonomy. One of the F-16s will be a Model D, which means it's a 2-seater, which means I get to ride in the back. This was one of the conditions. You got my support? Make sure one of those is a D. So I think again, just backing up to innovation and breakthroughs and brilliance, that doesn't come from me. I enable that. I mean, the trick is for me to be able to recognize it when I see it, right? And when I see it, and supporting those people, because there are many headwinds. The Air Force is a big ship. There are many traps along the way. But again, if we're focused, if we know in our hearts that this is the right way to go, if we have the passion and the dedication and the arguments, then we win our colleagues over and we make things happen. And again, it's amazing when that happens. I mean, my goodness, what a feeling, right? I mean, I remember, again, I went and hugged the person from the engine room, from our AA. These are the people that do our long-term planning. And, they are not particularly beloved in the Air Force because these are the people that say no to you. Like, I want $1 million to do this, or I want $100 million to do that. And they say, no, ma'am, not this year, come back next year. I was so excited because they said, this is easy, we're going to make this happen. Oh my God. So, it is amazing. And it is something that I think you only experience in the Air Force, in the service. Again, DARPA was an amazing experience. But, DARPA is off in Boston, they do their thing, and once in a while they have a home run. In the Air Force, what we do matters today.
Right.
And in the future, but today.
Right.
And for me, solving these practical problems, today's problems that affect, they affect our nation. But I gotta tell you, they affect my colleagues. These pilots that I fly with, these are the people that will be the tip of the spear. Their welfare, their well-being, their ability to come home in one piece, that matters to me so much. And having the privilege of being able to help them is just amazing. Sometimes I have to pinch myself. It's like, really, they let me in here? It's the best job in the world. After that.
Awesome. Coming back to, we talked about microelectronics, and of course, I introduced at the beginning, your role in, looking at science and technology policy, and we talked about that, per what you've been involved in at UC Berkeley. But the other aspect of that work has been, as mentioned, these tools to counter so-called digital authoritarianism. And I came across this really interesting article that you and former U.S. Homeland Security Secretary Janet Napolitano wrote in Foreign Policy magazine, March 2022, entitled "Digital Human Rights Need a Single Home in the U.S. Government," where you talk about how if everyone is responsible for countering digital authoritarianism, no one is responsible. And then this use of information technology to surveil, repress, and manipulate domestic and foreign populations. There's no focus anywhere in our government tasked with this particular task, which is important. Can you say a few words about sort of your work at Berkeley on this topic, but also sort of where we are with digital authoritarianism having a home somewhere in 2023?
This is our hope, right? So maybe this is the next big thing that we're going to bring home. It will take time. It will take time. Let me maybe just reflect back and tell you how it is that I got started down this path.
Please.
So when I was the CTO at the Wikimedia Foundation, one of the things that happened was the site was blocked by the government in Turkey, and they did that because one of the contributors wrote an article. Actually, there were 4 articles that talked about the deals that Erdogan's son-in-law was doing with ISIS around oil.
Yeah.
So the Turkish government, got in touch with us at the foundation, and they said, those articles, take them down. And we said, no, we don't do that. No, take them down, otherwise we'll block you. And we're like, sorry, we don't do that. So they blocked us. And because, by the time this happened, we were completely on HTTPS, which means that they didn't know. I mean, before that, they could censor on a per article basis, right? Because before encryption, they could know what article you were trying to read, and they could say, no, this article you can't read. Once HTTPS was deployed end to end, they could no longer see that. So then, the only tool that they had left was to block the entire site, and they did that. So, people in Turkey didn't have access to Wikipedia to either contribute or read for over 3 years. At the same time, I got involved with a group of people that are trying, and these are my colleagues at Berkeley, that are trying to break through the Great Firewall of China to get information into the Republic. It is an incredible battle, if you like, struggle that they are fighting. And I think that we honestly will fail to appreciate how dangerous and stressful what they do is. So in my time at the foundation, I was fortunate enough to be included in a set of workshops that were conducted in Taiwan on this topic.
Mm-hmm.
I can tell you, I was shocked at the amount of security, the extent of security that they had to deploy to make sure that people that were gathering to even talk about countering censorship in China had to go to stay safe. I work in the Pentagon. We know a lot about security, right?
Right.
We take care of security. I was shocked at the amount of, and I thought, what is going on here? And the more I learned, the more alarmed I became, not only, for the people in the Republic, but our ability to project messaging, our ability to tell them what our point of view is, and our ability to tell them, for example, that COVID-19 is a thing, and if your government is censoring, everybody who is trying to communicate that, actually it is a thing. Don't go home for Chinese New Year's because you're going to spread it to everybody, which is exactly what happened, right? So as you start looking into this more and more, you realize what a massive problem it is. But also you realize that, China and other authoritarian regimes, they're very well organized around this. I mean, they have their central internet authority, right? They have 1 million or more people whose job it is to become censors. What do we have? If you think about, democracies, what do we have? Well, we have a few, I will call them, internet freedom fighters, right? That are producing systems like Tor and others. But we don't have, we're not anywhere near having a systematic response. Because, even if somebody produces an innovation, how do we make sure, for example, it's deployed in all the browsers that people use? With censorship, you can say, well, okay, we can use a VPN. Sure, some people are savvy enough to use VPNs, but you know what? The VPN that you use is a client-side solution, which means, if I'm able to stop you in the street and search your device, which happens, it's very common, I can see that you have a VPN switched on. I can throw you in jail and do worse. So it's not okay to say, VPN is the solution. Actually, it's not the solution. The solution is to start pushing those technologies further and further into the network and away from the client so that the person that is using them cannot be identified. So, that is a massive technology agenda that, DARPA and other agencies need to work on so that, we understand how to counter censorship. But also at the same time, there are concerns about, okay, so now you have obfuscated or obscured all this traffic. What about the dark web? So Tor is, could be a heaven, right, for those that want to and do, do bad things, child pornography, drug dealing, what have you, right? So technology, can cut both ways. And like we say in the paper, technology doesn't know, technology is not good or bad. It doesn't know how it's going to be used. It's the context that determines if the use of a technology is a good thing or a bad thing. But who sets that context? Law. How can that policy and law set the right context if we don't have those conversations, if we don't have folks in government in the right places having these debates? Forming both themselves, but also, frankly, Congress, so that we write the right laws that allow us, to be purposeful and deliberate in how we use these technologies. And more to the point, how do we, if we don't have these policy frameworks, how can we get our point of view across to others? China exports digital authoritarianism in more than 60 countries. What's the counter to that? why wouldn't we, as a nation that is built, on freedom of speech and our core values as America, why would we not want to have a point of view that we can share with others, with our allies? Why can we not be a force for good on this as we are on many other things? You can't do any of these things unless you have focus and a place in government that is endowed both with technology, but also with the ability to combine that technology with policy and frameworks to make it executable. I think it's one of the most kind of insidious and vicious gaps, if you like, in what we have today. And I mean, all I have to say to you is what is it, ChatGPT. So over the holidays, everybody got excited about a new chatbot from OpenAI. And you look at it, it is very convincing in the narrative it generates, and it's completely full of misinformation. So I mean, take that. If you use a chatbot like that to do a search, for example, in Wikipedia, where you know that the corpus is curated, if you use that to do a generalized web search, it will give you a whole bunch of misinformation, but it will present it to you in such a compelling way that you will believe it unless you know better, right? So how do we think about that capability? How do we make sure that it's used for good versus evil? How do we make sure that China, for example, doesn't use it so that now they don't have just 1 million sensors, they have hundreds of millions of sensors? I mean, the scale it is just unbelievable. It's unbelievable. I mean, earlier this morning I was meeting with Secretary Rice, Condoleezza Rice here at Stanford, and we were talking about this topic. And she said to me that dictators can only dream of having that kind of capability. She's right. She's right. So we can't in all consciousness continue to ignore that. So I mean, as you can tell, I'm very passionate about. I think it's a huge challenge, but I do think it's one of these areas where, with focus and and deliberate action, we can make a ton of difference. I really believe that.
Thinking about this theme, continuing in the sense of technology for good and not for evil, I neglected in the bio intro to the show to talk about your leadership of the public benefit corporation in Silicon Valley known as Atlas AI, where you were developing artificial intelligence solutions for sustainable development, looking at ultimately how this AI tool, which some people think is kind of scary or could be used for bad stuff, but has a tremendous amount of good applications, looking at things like water and sanitation, financial products, ultimately boosting sort of access to these very hard to reach areas of the world. Talk a little bit, if you would, about your time leading this organization, because I think it's a very interesting part of the story that I neglected to mention at the beginning.
I'm happy to. I think with Atlas AI, I made a very deliberate kind of decision to, and it was a very hard decision actually, to leave the foundation and go, help set up this company, because it was mission focused. And I think it's been a kind of a consistent theme, and I continued at DARPA and also now at the Air Force. So Atlas AI gave me an opportunity to help build the company. It also gave me an opportunity to learn, really firsthand, not watch others, but like be in it. How you raise money, how you raise capital, even for a Stanford spin out, with AI in its name, it wasn't trivial to raise money. It gave me an opportunity to truly understand how venture capital works, which now I think, is a great kind of experience to have as we try, for example, to accelerate our own efforts inside of the department with AFWorks. I know you had the opportunity to speak with Ken O'Diller. They've been doing incredible work. A lot of the work that they have been doing was, in my view, just so badly needed. If you're the CEO of a company like that, especially post CFIUS and post FIRMA, which was legislation that further restricted in the ability of the Chinese and others to invest in critical technologies, which was really sorely needed.
Yep.
It had the expected consequence. A bunch of capital left town, but we, as the United States, did not replace it with good capital. So, many of us, including me, while I was outside of government, felt that reforming the SBIR program to be more like America's seed fund, if you like, which is what the NSF calls it, was the way to go. And the Air Force, really led the way in that. I think AFWorks and SpaceWorks have done incredible work. I mean, clearly, we continue to learn and evolve, but, they completely transformed what SBIR was to, I think, a really strategic tool in our toolkit. So, back to Atlas AI, I had the opportunity to go out, raise money. I don't think I've ever dealt with this many lawyers. Like when you close a round, I believe there were 7 different sets of lawyers that I was working with. It made my brain hurt. We did it. So I learned how to do that, and I'm really grateful for it. Our product was really quite incredible. So the founders, all 3 of them, professors at Stanford, very, very bright. We were able to use, deep learning technology to build models in areas where there was very little data to allow us to create insights about certain economic outcomes, and the company is still working on this, as well as energy, for example, which is what they do now, but also agricultural outcomes. And this is the incredible thing. I mean, I remember doing my due diligence before I joined them, and I was just amazed at how good this machine learning work that they were doing was. You could take any village in Africa, and with about a 75 to 80% confidence, you could tell whether they had $5 disposable income a day or $3. Think about it. And how did we do that? Using open source satellite imagery. I mean, fancy, 30-meter resolution, which is Neanderthal, right? I mean, we have much better stuff like that in the government. And some very sparse data from the ground that we had from surveys that the World Bank was conducting every 5 years, to create a model that we could use to predict or forecast, if you like, economic outcomes from all over the continent. So this is like something called transfer learning, which is, I mean, again, it worked remarkably well. We did the same thing with agricultural outcomes, and that was even more mind-blowing. 1 square meter, so you could take a plot in Kenya, a 1 square meter plot, and with about 55 to 60% accuracy, we could tell you 1 month before harvest how much corn, how much maize you would harvest. It's incredible. I mean, these countries, they have so little data. So in the case of maize production, without having that, they need to hedge and buy, very expensive corn from companies that, they have these ships that are sitting out in the Indian Ocean. And one day the government has to decide, will I need to import corn this year, or will I have enough? Without the kind of data that Atlas AI was creating or is creating, really it was guesswork. And, it's not like these governments have a lot of money to spare in the first place. Buying this extraordinarily expensive grain when they didn't need it, for example, was really not the best use of their resources. So, we enable them to be able to make these deliberate choices. In the case of economic outcomes, the development field, they needed data in order to be able to figure out where to go make those investments in the first place, but then also to see if their investments had the desired outcomes. Whether, if I was the Gates Foundation and I went and made an investment, say, in agriculture in Kenya, did it actually improve economic outcomes for those people? there's really zero data on the ground to be able to make those determinations. So Atlas AI was able to give them good enough data to make those determinations. I will say that, I mean, two things. I want to talk a little bit about both the kind of the power, but also the limitations of machine learning. And I think that is something that we in the Air Force and broadly in government need to be very thoughtful about. The amount of data that we were able to to generate on the basis of our models was mind-blowing. But it was particularly useful in Africa where there is no data. So, the difference between no data at all and data that's 50 to 60% reliable, it's, 50 to 60% improvement, right? That's a huge improvement. Where you already had enough data and, you were playing with a 5 or 10%, probably our data wasn't the best to get after. In reality, companies like Atlas AI are finding the application domains where machine learning can uniquely be successful, be useful, because there aren't many other things to do. There aren't many other options for getting the same outcome. So in the case of the financial product, what would you do? You could go around every household in Kenya and do a survey. And we all know how much that costs and how often would you have to do it. I mean, it's just not possible. There are other areas where people are thinking about using machine learning that are actually not the best places to use machine learning. And sometimes we fall into this trap of thinking that it's it's the solution for everything. It's
Right.
for everything. And sometimes you got to go back to and use your differential equations. Use math for a whole bunch of problems. There's physics, there's math. We know how to do that.
Yeah.
We should be careful, not to lose our minds, right, and forget all this physics and all this math that led us to the ability to create, semiconductors and microelectronics and software so that we could run machine learning models.
Yeah.
It's a tool that can be truly amazing if built and specialized in the right application areas.
Yeah.
And it can be completely useless and also, frankly, distracting from the right methods in places where where it simply doesn't fit. And I guess that go back to the chat GPT topic for a moment.
Sure.
So why is it, if you think about it, why is it that model, sometimes, works really well and most of the time gives you misinformation? Well, what is different now, because companies like NVIDIA have been able, to really get very high performance, low power GPUs harnessed. We've gone from the time where, in order to do any kind of speech processing or natural language processing, you needed to build a very dedicated model that was domain specific. So, for example, if you were, in fact, the very first application of speech recognition was done at SRI when I was still there. It was about Schwab. So if you wanted to do trades, you would build a domain with the terms and the things that a person was likely to say if they wanted to do a stock trade. If you wanted to buy an airline ticket, that was a different model. If you wanted to buy a railway ticket, it was a different model. What's happened now, because our hardware has gotten so much better, is we have a single very large language model. And that's what the server farms that NVIDIA has host. This very large language model is unconstrained. So if I go in there and ask a question and it doesn't have the answer, it will give me something back. But the problem is there's no guardrails. For example, this model doesn't understand ordinal numbers. So if I say, I have 3 sons, my first son is called George, and my second is Paul, and my third is, Nicholas. And then I ask it, what's my second son? It will say my second son is George. His not like the simplest deduction that a human being would make, it's not able to make it. It's very smart, right? It can tell me lots of things about, I don't know how to write code. It can't tell me that. Why is that? Because there are no guardrails, right? In the old days, we had expert systems that were actually rules, right? That told us, with this, with this likelihood, these are the things that are likely to be correct. And you can see it now. You can see me. I'm using my crystal ball here. My that 5 years down the line, you will begin to see, expert systems coming back and being fused with these very large language models, so that we can begin to cut down the amount of nonsense that they generate, right? And we have better outcomes overall. It's a fascinating. It's a fascinating time, to be a computer scientist. And, I think I've been very privileged, and I know that we're coming up to the end of the hour. In my career, I've watched our discipline change so much, and it continues to change. It's been such a ride to be part of that and being able, in some small ways to contribute. And now, at the coming to the end of my career, I feel really privileged to have known all this, to have learned all this, and be able to bring it to the Air Force, right, at the place where it really matters. It's fascinating. It's kept, the old brain engaged all these years.
It's been an amazing journey. I realize we're coming up against a hard stop at the top of the hour. I just wanted to throw one last thing in while I have you. But you've talked about your journeys on the F-14 and the F-16, and obviously you talked about the autonomy side of what's potentially coming. Can you just say 30 seconds worth about speed? I know you've been involved in certain conferences on hypersonics, and I know that's a whole separate area, but am I going to be able to get to Tahiti in a half an hour anytime soon from here in Philadelphia? I don't like to fly long distances, so if you get me there fast, I'll be happier. Are we making any headway there?
So the question is, you're going to get there in one piece or multiple pieces? So
I just want to sit on the beach and
well, I think that's probably still in the future, perhaps in the distant future. But we continue striving to get there. I think we with hypersonics, we've had some really good wins in the Air Force in coming up to the holidays. I'm very excited. I mean, I remember back in December of 2020, we had a pretty successful test at DARPA. We fired a 3-stage booster, and all 3 of them fired. It was a really good day. These technologies, in comparison, with my my exquisite, perfect world of bits, when the real world, when physics, intervenes in your designs, it's a very, very different environment. I've learned, in the last few years to be much more appreciative of what the real world throws at us in terms of challenges. The pristine world of computer science is great, but in order to really move the needle in some of these areas like hypersonics, we really need to get much better at our models, at our simulations, at our testing abilities. Building a hypersonics weapon is arguably one of the most complex challenges that we face today. But it's a challenge that our community, inside and outside the Air Force, including our defense industrial base, they're really up for it. I'm very excited. I'm very excited to see companies like Straton Launch, for example, be part of the picture, because I do think that we're not going to do all this by ourselves. We're going to do it in collaboration with other. A huge believer in leveraging the wisdom, the investments, the brilliance of the private sector for the work that we do. And it's wonderful to see them making the investments that will allow us, to do what Mr. Musk is doing, right? So he's able to fire a rocket once a week. I'd love to be able to do that. I mean, we do maybe once every 3 months, if we have if everything falls in place. So I think this fusion between commercial and government is something that will really be transformational for our our capability to defend ourselves and defend the free world. I'm just so excited to see this fusion finally beginning to take shape.
Yeah, it's going to be a very interesting coming years. Dr. Coleman, it was an honor having you with us today. I really appreciate you spending the time to talk about your journey and your future visions, and just really wishing you the best with everything you have going on there. Again, for everybody that's going to be listening to the show across the various podcast networks or watching on the YouTube channel, you've been listening to Dr. Victoria Coleman, Chief Scientist, United States Air Force. Dr. Coleman, it was great having you, and thank you so much for your time and sharing your knowledge and wisdom with us.
Thank you so much for giving me the opportunity. It's been a real pleasure.
It's great having you.
And happy New Year.